So I've actually decided to start recording this because I feel like once we actually finish this session, I can share this session with all of you, especially anyone who wants to see it again, or maybe those of you who might have missed today's class. So we started with a breakdown of our exponent rules with the purpose of creating index cards. So on one side, you can write down the rule, the name of the rule, and then on the back of the card, you can write the example or examples. So I've given 2 examples for most of them, but not all of them. This will help you to kind of jog your memory in terms of, okay, what do I do where? So this will be really helpful for building index cards. Perfect. The next thing we're going to do by request is to cover some of our solving of polynomial equations. So I can certainly come up with some examples where we can try these problems out. So what we can do for this first one, let me come up with a problem really quickly. Let's do this guy. Okay. So I'm going to go ahead and lower the page. The instructions will be to solve. So, and again, this is being recorded. So if you miss anything, not a big deal. I will send you the link, I promise. So we're going to go ahead and solve. So let's take a look at problem number 1. Let's say that we are given x squared is equal to 10x minus 25. So notice here that because we see an x squared, this should automatically trigger the idea of, okay, wait a second, we have to start by setting this equal to 0. That's incredibly important to start off with. So how would I set this equal to 0, Lindsay? Oh, the audio's not working. That's okay. I can take care of it.
Oh, no, sorry, it's that. I thought I was unmuted. Sorry, I thought I clicked it. By moving the x squared over, or you can move the x or the 10x minus 25 over the other side.
Let's do that. Since your x squared is your largest term, this has degree 2, this has degree 1, this has degree 0. Let's bring over the linear and the constant term to the left. So we're going to subtract the 10x. And we're going to add the 25, right? Opposite operations to move to the opposite side of the equation. Notice how I brought those 2 right over. So let's go ahead and rewrite this. We notice that those 2 terms on the right-hand side cancel out. So that leaves us with equals 0. And we're left with x squared minus 10x plus 25. Keeping in mind that those are not like terms, so we cannot just combine them. Our first step was to set equal to 0. That part's done. Remember, there was a 3-part process to solving polynomial equations. So solving polynomial equations. What was that second step?
Factoring.
Yes. So let's go through this process of factoring. I'm looking at this trinomial. Does anyone know what's the name of this technique that we're going to use to factor?
Trial and error.
Trial and error, yes. So we're going to go ahead and use trial and error. That means we are going to say what A, what B, what C is. So we have A is equal to 1, which is exactly why we chose trial and error, right? A trinomial whose leading coefficient is equal to 1. B is a negative 10, and C is a 25, a positive 25. So what we do is we end up multiplying A times C, so 1 times 25 is 25. And our goal is to find factors of 25 that combine to give us a negative 10. Does anyone see those factors right off the bat?
5 and 5.
Yes. Tell me more about the signs, positive or negative or both. What do we got here?
They would both need to be negative?
Yes, beautiful. And let's double check that. A negative 5 times a negative 5 is in fact a positive 25. Negative 5 minus 5 is a negative 10. So these are the 2 factors that we need. Because we're using trial and error and not AC grouping, we can actually go right into the factored form. Notice we're going to break x squared down into x and x. And then of course we have these two factors of 25. So -5 times a -5 is a positive 25, where when we combine these, we get a -10. So we've got -5 minus 5. So in solving polynomial equations, step number 1 was to set equal to 0. Step 2 was to factor, while step 3 is then to
Solve.
yes. So we're going to set each factor containing a variable equal to 0, and we solve. It just so happens that in each case, my x is going to be equal to 5. So we could write x is equal to 5 and 5, or you could just say x is equal to 5. You don't need to duplicate that same result. It is okay to say x is 5. What questions do you have for me on problem number 1?
It's a little bit confusing.
Which part?
Like the trial and error, the first part, like how you like actually set it up.
Like in this part?
Nope, it's where you see like the x squared equals like 10x minus 25. Yeah, it's a little bit confusing.
So keep in mind that our goal is to set this equal to 0. So we have to bring this 10x over by using the opposite operation. So since it was a positive 10x, we have to subtract the 10x to bring that over. Then we have to bring over the minus 25. So in order to do that, we do the opposite operation, which is a plus 25 to bring that over. Once we've brought both of those terms over, they cancel, leaving us with 0 on the right-hand side of the equals. On the left-hand side are all of these terms, but in descending order, it is x squared minus 10x plus 25. Once we
Sorry. So what about like to find out, like we have to see what equals to like 25?
Yes. So once we're here at trial and error, which we recognize as a technique, we then list out what A, B, and C are. And then we say factors of AC, A times C, that combine to give you B. So factors of AC that combine to give you B.
What happens if the 25 was a negative? Won't
If the 25 were a negative, then this also cannot be a negative 10x. There would have been something else going on there. But you still have to be able to find factors of AC that combine to give you that B. So they have to satisfy both conditions in order to be the correct factors. Good. Janae, have you had an opportunity to watch my video on trial and error?
I mean, I watched a little bit of it, but I need to watch some more.
Okay, good. If you completely watch the trial and error and the AC grouping videos, that's going to answer a lot of these questions for sure. Okay, it will help. Just make sure you sit with that whole content. Okay. Good. I do have another one that I'd like to try with you just to make sure that we're all on the same page, if that's okay. So how about, let's look at number 2. Same exact thing. We are going to solve. Remember, I am recording this, so don't feel like this is going away. Okay, let's look at number 2. Perfect. So let's say that you are given 6x squared plus x is equal to 15. Again, we see that x squared term. So immediately I want you to start thinking, oh, I'm solving a polynomial equation. We learned that in order to do that, step number 1 is to set equal to 0. Step 2 is to factor. Step 3 is to solve. All right, anyone, how would I set this equal to 0?
Add 15 or minus 15.
Good. We're going to use the opposite operation to bring this term over. So we're going to subtract that 15. That's going to leave us with 6x squared plus x minus 15 is equal to 0. Step number 1 is complete. Step 2 says we have to factor. So someone else, what factoring technique would I use in this case?
Could you do AC grouping?
Yes, perfection. That is absolutely correct. AC grouping. Arnold, how did you know this was AC grouping? What kinds of things did you think about as you were looking at this polynomial?
Well, I was looking at it and you can't really like there's nothing that you could factor with the numbers with. So I just decided to like factor out the numbers. So A would be like 6,
Good.
B would be 1, and C would be -15.
Yes, I love it. We have a trinomial whose leading coefficient is bigger than 1. Immediately AC grouping. I love that, Arnold. That was fantastic. So according to the name, this says take A and C and multiply them together. So if you need to, you can go ahead and grab your calculator. You can use your cell phone, whatever you'd like, because you are at the comfort of your own space right now. So I'm going to take
Yeah.
6. What is it? Go
You
ahead.
said multiply, right?
Yep.
Oh, won't that give you -90?
Perfect. So now what we're going to do is we're going to find factors of -90 that combine to give us a +1. That's kind of crazy. Does anyone see those factors right off the top of your head? What times what will give you 90? And then when you combine them, you get a 1.
9 and 10.
Yes, a 9 and a 10. Tell me more about those signs.
-9.
Good. Let's test it out. -9 times 10 is going to give us a -90. Love it. -9 plus 10 is going to give us a +1. We have just found the two factors that are going to work. So that takes care of the AC part, but we haven't done anything with the grouping part. So we have to fix this now. We learned that if you're going to factor by grouping, you need 4 terms, but I only have 3. So what that means is you're going to take your middle term and you're going to replace it with the 2 factors that you found. So that means this becomes 6x squared minus 9x plus 10x minus 15 is equal to 0. Notice that that positive x became the 2 terms, a -9x and a positive 10x, because -9 plus 10 is 1. So all we've done is we've rewritten the polynomial so that now it's 4 terms, because once it's a 4-term polynomial, we can factor by grouping. So let's go ahead and actually factor by grouping now. So you group the first 2 terms and you group the last 2 terms. Out of the first 2 terms, I want you to notice that we do have a GCF, right? What is that GCF? Go ahead and shout it out.
2x.
Will 2x work?
3x.
3x, perfect. So we're going to take a 3x and divide it out of each term. 6x squared divided by 3x is going to leave us with a 2x. A -9x divided by a 3x is a -3. Out of the last 2 terms, what do you see as your GCF? Go ahead and shout it out.
5.
Yes, a +5. We bring down this plus sign because that's what divides the 2 terms. We went from 4 terms. Now we're going to go to 2 terms by finishing this statement. We're going to factor out a 5. So a 10x divided by 5 is a 2x. A -15 divided by 5 is a -3. And so far, so good. I've almost completely finished writing my factored form. I want you to notice we have that common 2x minus 3. I was going to look for my highlighter, but that's okay. So we have a common factor of 2x minus 3. So we're going to take that out of both terms. And if you take that out of both terms, you're left with 3x plus 5. And now we have finished factoring. So step 1, set equal to 0, that's completed. Step 2, you actually factor, that's completed. Now step 3 is to solve. So you're going to take each factor containing a variable and you're going to set it equal to 0 and you're going to solve. So we have 2x minus 3 equals 0. and we have 3x plus 5 is equal to 0. We're going to go ahead and solve this first equation. You're going to add the 3. So we have 2x is equal to 3, and then we're going to divide by 2. So we find that x is equal to 3 over 2. We're going to solve this second equation, similar idea. We're going to subtract the 5. We have 3x is equal to -5. And then we're going to divide by 3. And we have just found the 2 solutions for this problem. Okay, you know you should have 2 solutions because our degree is 2. So our degree is 2, you should have the 2 solutions. If your degree were 3, you'd have 3 solutions. Go ahead, what questions do you have for number 2?
Do you think this is like the level that we're gonna see this kind of like on the test, or do you think it's gonna be a little bit harder?
No, I think this is pretty on par with what you would expect to see on your test, because you learned 4 different factoring techniques, which means I want to see all 4 of those techniques. You should be able to take a 4-term polynomial and factor by grouping. You should be able to take a trinomial and factor by trial and error or AC grouping. And then finally, you should be able to take a binomial and potentially factor as the difference of 2 squares. Remember that no matter what happens, your first step of factoring is always GCF. So you need to look for that GCF first and then see, can you factor further? Okay, that's going to be incredibly important to the process.
How do you know it was 3? Like for as the GCF.
Joshua, you were supposed to email it at 1. You can email it at the end of class. You can take pictures and then send it over. So when you were mentioning how did you know it was 3, and you're referring to this part right here, the 3x.
Yeah.
You look at the 6 and the 9, and you look for factors of 6, and you look for factors of 9, and then you see what they have in common. So for instance, if I were to write the factors of 6, it's 1 times 6 and then 2 times 3. If you look at factors of 9, it's 1 times 9 and then 3 times 3. So they both have a common factor of 3.
Oh, okay. Okay.
You can actually always do that. If you're ever looking for common factors, like I know you didn't ask about the 10 and the 15, but I can show you. So 1 times 10, 2 times 5, 1 times 15, 3 times 5. And then we're like, oh yeah, sweet. They both have a 5 in common. So that's how you can actually look for common factors. Excellent. I want to do one more, maybe more than just one more, but I'd like us to solve this one as well, because I think it's a really good, it's good exposure. Take a look at problem number 3. The instructions again are to solve. So let's say that I gave you 3x squared minus 21x is equal to 0. What are your thoughts on a problem like this? 3x squared minus 21x is equal to 0. So what's going on in your mind?
GCF,
GCF. What is the GCF?
3x.
Interesting. So if I take that 3x out, what am I left with?
X minus 7?
Perfect. Can I factor either of these more?
No.
No. Now that I have factors, so step number 1 set equal to 0. That was done for us. Step number 2 is factor. Now I have completed that. Step number 3 is to solve. You set each factor containing a variable equal to 0 and you solve. So here's the first one, 3x is equal to 0. And here's the second one, x minus 7 is equal to 0. Now I can solve for x by dividing by 3. So we have x is equal to 0. And then of course I'll add 7. That means x is equal to 7. And those are the 2 solutions. Good. I wanted you to see that sometimes all you have to do is take out the GCF. Sometimes you can't factor further. That's literally as far as you can go. How about one more?
You
Oh, yeah.
always, you want to always write x is 0.
If you have a 3x equals 0, you have to solve it. So
Right.
you'll divide by the coefficient, and then yes, you do have to say that 0 divided by 3 is 0.
Okay.
Good. I have another one that I'd like us to take a look at. Let me just punch this into my calculator real quick. How about this one, number 4? 5m squared minus 80 is equal to 0. So someone else other than Amanda, Amanda's on a roll. Someone else, jump in here. What's the first thing you're going to do here? First off, we know it's already set equal to 0. So step number 1 is done. Talk me through this next part. What would you do?
You should factor.
Yes, factor out what, Arnold?
Factor out the 5.
Let's do it. If I take the 5 out, what am I left with?
M to the second minus 16.
Yes. Are we done factoring? Can we go further?
Yeah, you can go further.
Perfect. Tell me more.
You can factor out the M2. I mean, you can. Okay, so you can do like 5, and then on the outside, and then it'll be 2 of the parentheses, 2 sets of parentheses, and it'll be M minus 8 and M plus 8.
Oh, you're so close. Is it an
Or-
8?
Oh, 4. It's 4. It's 4.
Yes, perfect. What technique did you use?
Was it grouping or?
No, not grouping. Grouping is 4 terms. Back them up. What technique did he use?
Difference of 2 perfect squares.
Perfect. Difference because it's a subtraction. And these are both perfect squares. So difference of 2 perfect squares. That's what allowed you to factor it as a plus b, a minus b, or in this case, m minus 4, m plus 4. Good, very, very nice. And now we're ready to solve. Notice that this 5 does not have a variable. So technically, if I wanted to, I could divide both sides by 5 and it would totally get rid of that 5. So I'm essentially going to leave that to the side and say, well, I have m minus 4 equals 0, and I have m plus 4 equals 0. Those are the 2 equations we're going to solve. Keep in mind, our degree is 2, so we should be expecting 2 solutions. I'm going to add 4 here, and I find that m is equal to 4. And then I'm going to subtract 4 here, and I find that m is equal to negative 4. And those are my 2 solutions. I want to remind you all that unless the problem says to solve, you're not going to solve, okay? So there will be some problems on the test where all I'll say is factor. That does not mean you introduce an equal sign with a 0 and then you solve it. Please don't do that. I have seen countless students turn an expression into an equation and then solve, which is a huge bummer because I'm thinking, why did you do that? Why did you go so far as to create a problem on your own? So if there is no equals, do not introduce one into the problem and then solve. There's a huge difference between just factoring and then actually going through the process of solving, okay? Lindsay, you had requested these kinds of problems. Did we touch base on this topic enough where we can move on to the next?
Yeah, I think I'm good.
Okay, perfect. Anyone else? What other topics would you like to see? Okay, so what I'm going to do now is I'm going to create a problem where we'll have to calculate the slope first, and then we'll state the slope of a line parallel and then the slope of a line perpendicular. So let's go over to my notes. Okay, so let's take a look at a particular example. So we want to find the slope. The cool thing about your final exam is that you are going to be given the formulas on the very first page so that you can use those formulas to your advantage. I think some of us are neglecting this and we're not going back to the formula page, which is a huge bummer. I've given you the formula so that you can use them. There's no pressure to remember them, so please use your formulas. So let's find the slope between the points -5, 7, and we'll do 1, -3. So in order to find the slope between these 2 points, we have to use our slope formula. So as a reminder, m is going to be equal to, which by the way, m is slope. M is going to be equal to y2 minus y1 over x2 minus x1. What is going to be helpful to us is recording what is x1, y1, etc. So here's our first point, which we'll call x1, y1. Here's our second point, which we'll call x2, y2. Now that I have labeled my ordered pairs, it's going to make this a lot easier when I actually make the substitutions. So we've got -3 minus, right, y2 minus y1, -3 minus 7, all over, and then x2 is 1, minus, and then x1 is a -5. That negative in the 5 doesn't go away. We have to take that into account. I'm going to go ahead and do the math. This is going to give me -10 over, and then notice minus minus is a plus. So we have 1 plus 5, which is 6. Anytime you see a fraction, your goal is to always reduce. Make sure it's in this simplified form. Notice a 10 and a 6, they're both divisible by 2. So I'm going to reduce this, and that's going to give me -5 over 3. So there's my slope. The next thing we're going to say is, well, what is the slope of a line that's parallel, right? What do we know about parallel lines? Can anyone share with me?
They have the same slope.
They're equal.
Yeah, they have the same slope. So their slopes are going to be the same. So if your first line has a slope of -5 over 3, take a look at what that might look like. So let's say we plot a point. We're going to go down 5 units and then over 3. So here's what my first line could potentially look like. If a line is parallel to that, it's going to be literally right next to it, which means they don't ever cross. So if it were a system of equations, there would be no solution because they never cross. And because of that, we know that the slopes must be the same. I heard a question.
Yeah, I got a question.
Sure.
Well, since the parallel line is -5 over 3, won't it actually switch if it was like perpendicular?
Yes. So let's talk about that now. If we have a line that's perpendicular, what is its slope going to be?
Well, it'll be like, well, basically switch. So -3 over 5.
Oh, you're so close. Not negative, but positive.
Positive. Okay. Oh,
Yeah. So
okay.
two things have to switch. Good, good. 2 things have to switch. You have to change the sign, and then you have to flip the fraction. So there's 2 flips. And the reason for that is you want to make sure that they actually intersect, the lines actually intersect at 90 degrees. So if I draw another line through this one at 90 degrees, notice, for instance, here it is. Notice that my line here has a positive slope, whereas these lines both have negative slopes. Negative slope, negative slope. Here's a positive. This one I had to go down 5 over 3. This one I'm going to go up 3 over 5. So that is how those slopes play into each other.
I also got another question.
Yeah, sure.
If you like well, my bad. If you like plot -5, -5, 7, and 1 and -3 on the number line, will it give you like the same lines that's like
Well,
going?
yes, yes. So for instance, if I went ahead and I'll make a small graph. So -5, 7, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's approximately here. And then 1, -3. That's approximately here. When I connect these 2 lines, let me connect this with a straight edge. Perfect. I can then say, well, how do I get from this point to this point? And you're like, oh snap, I gotta fall a lot before I run. So if you were to count, you'll see that you're gonna fall 10 units and then you're gonna run 6, which of course is your slope here, fall 10, run 6. But remember, you have to reduce that. So technically you'll fall 5 and then run 3.
Was this pointing, like actually pointing at, I think that's -5. Yeah, -5 and 3. So yeah, basically you can see it right there.
True. I mean, you do, oh, you're looking at these values? No, don't consider these as part of what your slope is going to be. It doesn't work out that way. This just happened to be that the -5 and the 3 were in the slope. Do not
Okay.
consider that at all though, okay?
Okay.
Yeah, that's not a pattern. That's not what's happening. What's happening is as you move from one point to the next, you're going to fall before you run, and then you would reduce that.
Okay.
Good, good. I'm very glad that you had commented on that because we should clarify. Excellent. Arnold, does that help in terms of parallel and perpendicular?
Yeah, it kind of, yeah, it does clear it up. So thank you.
Can we do one more?
Yes, of course. So same thing, let's take this a step further. Let's find the equation of the line. So we are going to write the equation of the line in point slope and slope intercept form of the line going through, and now I'll come up with some points here. So let's say that my points are we'll do 2, 6, and we'll go -1, -5. So 2, 6, and -1, -5. So I want to find the equation of that line in 2 forms, point slope and slope intercept form. Because we have 2 points, we need to start by finding the slope. So again, we're going to label this x1, y1, and then x2, y2. Let's use the slope formula. M is equal to, we've got y2 minus y1, so -5 minus 6 all over x2 minus x1, so -1 minus 2. -5 minus 6 is in -11. -1 minus 2 is a -3, and you know for a fact that we can simplify this because the negatives will cancel. So my slope is simply 11/3. The next thing I want to do is I want to go ahead and write point slope form. I love point slope form because really all it is just plugging in the numbers and that's it. You don't even have to do anything really special. You just plug into your point slope form. As a reminder, point slope is y minus y1 equals m times x minus x1. So we have that as our foundation. Now all we have to do is just plug right in. So we have y minus, now y1 is 6, equals m, we found it, we did the math, that's 11/3, parentheses, then we have x minus, x1 is 2. And I just found point slope form. That's half the formulas, right? We needed the point slope and slope intercept. Here's one of them. Now, in order to find slope intercept, it's going to be helpful to take that point slope form and actually do the math to get y by itself. So in order to make this happen, we're going to have to distribute the 11/3. So let's go ahead and distribute. That gives me y minus 6 is equal to 11/3 times x is just 11/3 x. 11/3 times a -2 is a -22/3. Now I'm almost there. Slope intercept form is y equals mx plus b. Y is not by itself yet. So I'm going to add 6 to both sides. Now, in order to complete this, I really want to do a little bit of side work. So notice that I have a -22/3 plus a 6. But remember that 6 is over a 1. So in order to add or subtract fractions, I need a common denominator. I look at both fractions and I notice that the denominator, the common denominator, should be a 3. So to fix this, I multiply my second equation, numerator and denominator, by 3. Because remember, you want to multiply by 1. 3 over 3 is 1. So we're not changing the value, we're just changing the actual fraction by updating it. So we have negative 22 over 3 plus 18 over 3. And now that I have these two with the same denominator, I can actually finally combine them. A negative 22 plus 18 is a negative 4. And of course, you keep that denominator of 3. So that means my slope-intercept form is y is equal to 11 over 3x minus 4 over 3. And here's my last equation. So this one right here is slope-intercept form. Good. Does that help to see the whole breakdown, the whole process, Janae?
Yes, that does.
Beautiful. Very, very nice. Especially when it comes here to the fractions, just keep in mind there's naturally going to be a little bit of side work, and don't hesitate from actually showing them, okay? All right, everyone. On that note, we have 1 minute left, so I'm going to stop recording at this point.